Welcome back to Calbekistan, where anybody can learn math. My name is Mr. Calbeck. This is episode 4 in our Crash Course series. Today we're going to be talking about some weird cases in factoring. Today, this one is one such example. This is called a difference of squares. If you take notes on these videos, that'd be a great thing to write down. You can tell something is a difference of squares anytime you see there's a subtraction sign. The mathematical word for subtraction is difference, and then there's two numbers that are squared between that subtraction sign. So in this case you have x squared, in this case 16 is 4 squared. So that's really what we're looking for, subtraction and two things that are squared. What I'm going to show you does not work if this is a plus sign, so please don't try it, it will not work. Okay, at first glance this doesn't appear like the other kinds of factoring we've done, but it is in fact the same thing. The way that you can see it is if you realize that the middle term is missing. We can actually write it in though. Anytime you see a term that's missing in math, you can replace it with a 0. So what I'll do is I'm going to rewrite this as a 0x and then minus 16. And what you'll see here is if you try to factor this normally, you're looking for two numbers that multiply to be negative 16 and add to be 0. You'll notice it's the same number twice, but one's positive and one's negative. So negative 16 will factor to negative 4 and positive 4. Be really careful. I see a lot of students try to do negative 1 and 16 or something that doesn't add to be 0. So be careful with that. It's got to be the same number so it subtracts out. That's going to give us the factors x plus 4 and x minus 4. Now if you look at this, you may see a pattern here. This first number is simply the square root of the first term. So if you take x squared and take the square root of it, you'll get x. The second term, 4, is the square root of 16. And you'll take the square root of that, gives you 4, so you have plus and minus as well. And that's the pattern. A lot of teachers will teach you there's actually a bigger pattern here, that no matter what you got, and whenever you're trying to think of any number, use a variable, so we're going to say a. If you ever see a squared, doesn't matter what that first term is, but it's squared, and it's subtracted with something else squared, you can factor it as a plus b and a minus b. It's the same number twice, added and subtracted. And you find these numbers by taking the square root of your original two terms. And that's the difference of squares. So let's do a more challenging one. Let's try something like this. How about 100 x squared minus 81. Now normally this would look incredibly daunting because you could rewrite this problem. There is a middle term, it would be 0x. But if you wanted to multiply these two first terms together, remember if you have a term that doesn't factor out, in this case 100 will not factor with 81, you have to multiply these terms together. Now if you want to multiply 100 times 81, it's a huge number. So these two multiplied together are going to give you negative 81,000, or 8,100, I apologize. 8,100. So I'm looking for multiples of 8,100 that add to be 0. Now you might not know your multiples of 8,100. I don't, as a math teacher. But we can use our trick here. Instead of trying to factor normally, we'll say, hey, this is a difference of squares. This whole thing is a squared, and this whole thing is b squared. So let's factor it. The square root of 100x squared, square root of 100 is 10. The square root of x is x, so the square root of 100x squared is just 10x. And the square root of 81 is 9, so it becomes 10x plus 9, because remember it's a plus b and a minus b. The other one will be 10x minus 9. It's way, way faster to factor this way. Anytime you see one thing squared minus another thing squared, you can do this. You can take a nice shortcut to factor it really quickly. Let's look at the other special case here. The other special case is called a perfect square. Now, perfect squares are pretty easy to factor. They're not anything scary, I hope. Here's an example of one. And you can factor this normally. Again, there's no leading term, so I'm simply looking for the multiples of 25 that add up to be 10, and 5 and 5 work. So you can factor this to make x plus 5 and x plus 5. Nothing particularly scary about that. The cool thing about a perfect square that your teachers will want you to do is if you ever see the same parentheses twice, you can rewrite that. So instead of x plus 5 times x plus 5, this is the same number multiplied by itself. So they're going to want you to write it as x plus 5 squared. So if you ever see this, what it really means is x plus 5 times x plus 5. Now, most of you are probably not going to make a mistake on a problem like this. What you'll make a mistake on is going the other way. If your teachers ask you to factor x plus 3 squared, what a lot of students do, and this is one of my least favorite errors, is they'll simply try to distribute an exponent in here, like this, and get x squared plus 9. But that's completely wrong, because exponents aren't regular multiplication, so they don't distribute. Okay? What exponents do is they multiply a number by itself. Here, instead of it being x plus 3 squared, what that really means is it's a perfect square, which means there's two of the exact same number, x plus 3 and x plus 3. So if you were to multiply it, it wouldn't give you x squared plus 9, it would give you x squared plus 3x plus another 3x plus 9. These middle terms will combine and give you a final answer of x squared plus 6x plus 9. So that's it for your crash course today on factoring, difference of squares, and perfect squares. Next time, if you stay tuned, we're going to be talking about putting all of these together and using them at once. So we're going to combine all of the first 4 episodes together in single factoring problems. Hope to see you then.